In this video, we're going to talk about properties of logarithms. The learning targets for this lesson are we're going to make conjectures about properties of logarithms, we're going to write and apply the product property and quotient property of logarithms, and we're going to rewrite logarithmic expressions by using properties. Before we start, we're going to do a warm-up of just reminding ourselves how logarithms work. Logarithms are exponents. They represent exponents. I want to know, for number one, what exponent do I need to raise 1/2 to get 32? And so what I could do is I could set this equal to an exponent, and now it's in logarithmic form. I can convert it to exponential form. So I could say, well, I have my base is 1/2, so I'm raising 1/2 to the e power, and that's going to give me my answer of 32, the thing that was inside the logarithm in log form. From here, I could rewrite both sides to be in terms of the same base. So 1/2 and 32, they share a base in common. That base is 2. I can rewrite 1/2 as 2 to the negative first power on the left-hand side. On the right-hand side, I could rewrite 32 as 2 to the 5th power. And then to simplify the left-hand side, if I simplify the left-hand side, I have 2 to the, if I have a power to a power, I'm multiplying the two powers together. I get negative e. It's 2 to the negative e power is equal to 2 to the 5th power. I know these two powers have to be equal to each other. So I know that negative e has to be equal to 5, or e has to be negative 5. So my this logarithm is actually, it represents negative 5. For this logarithm, I have log base 27 of 1 over 81. I know if I set this equal to an exponent, I could also read this using counterclockwise motion. I could say 27 to the e power gives me 1 over 81. 27 to the e power gives me 1 over 81. I know that 27 and 81, or 1 over 81, share a base in common. That base is 3. On the left-hand side, I could rewrite 27 as 3 to the 3rd power, and that's being raised to the e power. On the right-hand side, 1 over 81. Well, I know 3 to the 4th power is 81, so 3 to the negative 4th power would be the reciprocal, or 1 over 81. So this is 3 to the negative 4th power. I'm going to simplify the left-hand side to be 3 to the 3e power. On the right-hand side, I have 3 to the negative 4th power. I know 3e has to be equal to negative 4. I'm going to solve this equation, divide both sides by 3, and I see that e has to be negative 4 over 3. So the answer here is negative 4 over 3. For number 3, I have ln of 1. When I see ln, that means log base e. It just is another way of writing log base e. So really, when I evaluate these things, I like to change ln to log base e because it's easier to figure out. I have log base e of 1 is what I have here. I want to know, what do I have to raise e to get 1? What power do I have to raise e to get 1? And I can set this equal to, I'm going to set it equal to x, so it's a different variable. I could also write e to the x power gives me 1. E to the x power is 1. And I know that x would have to be 0 for the e to that power to be 1. So x is 0. Anything raised to the 0th power is 1. For number 4, I have ln of 1 over e. I'm going to rewrite the ln as log base e. So I have log base e of 1 over e. I'm going to set that equal to an exponent, but I'm going to use x again to represent it instead of e so I don't get confused, because e actually represents a number, not a variable in this case. I have my base is e. I'm raising it to the x power, and that's equal to 1 over e. That's my answer. I know 1 over e is the same as e to the negative first power, so I have e to the x power is equal to e to the negative first power. X is negative 1. Logarithm properties. These are things you can always figure out if you forget what they are, but they're just going to make your life faster if you memorize them. If I have log base b of 1, I want to know what that's equal to. I don't know yet. I'm going to figure it out by converting to the other form. So that's in logarithm form. I'm going to convert to exponential form. I'm going to let that spit out just a variable x. If I want to rewrite what I have in exponential form, I have my base is b, I'm raising it to the x power, and that's going to be equal to, I have 1 is my answer. What do I have to raise b to get 1? No matter what the base is, I have to raise b to the 0th power. Raise it to the 0th power to get 1. So I'm going to change this x. Instead of writing x, I'm going to write 0. I know if I have log base b of 1, it's always going to be equal to 0. For the next property, I have log base b of b. What's that going to be equal to? I'm going to set it equal to x to start. I'm going to figure it out by converting to exponential form. I have my base is b. I'm raising it to the x power, and that's going to spit out b. And I want to know, what would I have to raise b to get b? And that is, no matter what b is, it's always going to be 1. I raise b to the first power to get b. So instead of writing x here, I'm going to write 1. X is 1. For log base b of b to the y power, I'm converting to logarithm form. I'm going to set this equal to, equal to x again. I have my base is b again. I'm raising it to the x power, and that's going to be equal to, I have my answer is, what's inside of the logarithm is b to the y power. B to the x power, I want it to be equal to b to the y power. That's when x is equal to y. So I'm going to erase x. I'm going to replace it with y. And I'm going to erase this x and replace it with y. So if you have log base b of b to the y power, it's going to spit out y. For the last property, I have b to the log base b of x is always going to give me the same thing, and I want to figure out what that is. I'm going to set this equal to, I know this is going to give me an answer. This is exponential form. Base raised to an exponent is going to give me an answer. I'm going to convert this to logarithm form to figure this out. So I'm writing the word log. I know my subscript is going to be b because that's my base. I know inside of the logarithm is going to be a, and that's equal to, on the other side, my exponent is log base b of x. If I want the left-hand side to equal the right-hand side, what does a have to be equal to? Well, log base b of a is equal to log base b of x. A is x, so I'm going to erase a here, and instead I'm going to write x. If I have b raised to the log base b of x, so raised to a logarithm with the same base, whatever's inside the logarithm is going to be my answer. Let's look at examples. So for the first one, log base b of 1 is equal to 0. An example would be if I had log base 5 of 1, that would be equal to 0. 5 to the 0th power gives me 1. This, for the second one, log base b of b is equal to 1. An example would be log base 5 of 5. That would be equal to 1. 5 to the first power gives me 5. What do I have to raise 5 to get 5? That's 1. For the third property, I have log base b of b to the y power. I'm going to do is equal to y. I have, for example, log base 5 of 5 to the third power. What do I have to raise 5 to get 5 to the third power? That's 3. So 5 to the third power gives me 5 to the third power. My answer is 3. And then for the last one, I have an example would be for b to the log base b of x is if I have 5 raised to the log base 5 of 4. I know that's going to spit out 4, which is what's inside of my logarithm. All right, let's do some examples. Logarithm property practice at the bottom. I have log base 3 of 3 to the 5th power. That's going to spit out 5. If I have log base 7 of 7, it's going to spit out 7. Oh, I'm so sorry. No, it's not. 7 to what power gives me 7? That's the first power, so it's 1. For 6 to the log base 6 of 10, that's going to give me 10. For 7 to the log base 7 of 3, it's 3. For 5 to the log base 5 of 8, it's 8. For e to the ln of 6, this is the same as e to the log base e of 6. That's 6. For number 7, I have ln of e to the third power minus log base 2 of 1 over 16. I'm going to separate these two things. So I'm going to separate them and simplify each one separately and then bring them back together. So for what I've highlighted in yellow, I'm going to let this represent x, and what I've highlighted in purple, I'm going to let it be represented by y. So I'm going to say x is equal to ln of e to the third power. And what I can do here is I can change ln to be log base e. I'm going to do x is equal to log base e of e to the third power. I'm asking, what do I have to raise e to get e to the third power? And that's going to be 3. So x is 3 for what I've highlighted in yellow. So x is 3. Whoops. For what I've highlighted in purple, I'm going to set y is equal to log base 2 of 1 over 16. I'm going to rewrite this in exponential form. I have 2 as my base. I'm raising it to the y power, and that's going to give me 1 over 16. 2 to the 4th power is 16. So 2 to the negative 4th power would be 1 over 16, the reciprocal. So y would be equal to negative 4. That's the exponent I would need to raise 2 to get 1 over 16. So what my y is going to be negative 4. And then I'm going to add, I'm going to subtract these two. So 3 minus negative 4. That gives me 3 plus 4, which is 7 is my answer. For number 8, I'm doing log base 4 of log base 2 of 256. I want to do log base 2 of 256 first. I'm asking myself, what do I have to raise 2 to get 256? And you can check in your calculator if you're not sure, but that is the 8th power. 2 to the 8th power is 256. So I'm really doing log base 4 of 8. So I have log base 4 of 8, and that's equal to e. I'm going to set that equal to e, an exponent. I know it represents an exponent. I know 4 to the e power gives me 8, so I'm going to write that equation. 4 to the e power gives me 8. I want to rewrite both of these sides in terms of the same base. 4 and 8 share 2 in common, so I'm writing 2 squared is raised to the e power on the left, and 2 to the third power on the right. I'm going to simplify the left-hand side. If I have a power to a power, I'm multiplying those to simplify. So it's 2 to the 2e is equal to 2 to the 3. 2e has to be equal to 3, so e has to be equal to, if I divide both sides by 2, e has to be 3 over 2. For number 9, I'm going to separate these again. So I have, I'm going to separate this from this, and I'm going to do them, I'm going to simplify each of them and then bring them back together. For ln of e to the 14th power, this is the same as log base e of e to the 14th power. What do I have to raise e to get e to the 14th power? That's 14, so this is 14. So what I highlighted in yellow is going to be just 14 is the answer, or the simplified version. If I do log base 3 of 1 over 9, I'm asking, what do I have to raise 3 to get 1 over 9? And that is 3 to the second power gives me 9, so if I wanted the reciprocal, I would do 3 to the negative second power. So this is negative 2. This is negative 2, and I'm subtracting these. So 14 minus negative 2, which gives me 14 plus 2, which is 16. For number 10, I have log base 10 of log base 2 of log base 3 of 9. I'm going to start with the inside and work my way out. Log base 3 of 9, 3 to the 9th power, or what do I have to raise 3 to get 9? And that is 2, so I really have 2 inside here. So I have log base 10 of log base 2 of 2, because this here was actually 2. The next thing I'm going to do is log base 2 of 2. What do I have to raise 2 to get 2? And that is 1. So I'm actually doing log base 10 of 1. So this whole thing here is actually just 1. And what do I have to raise 10 to get 1? That's 0. I have to raise 10 to the 0th power to get 1, so the answer is 0. Let's talk about some other properties of logarithms, one being the product property of logs. We'll review by going over what is x squared times x to the 5th power. If I have the same base, I'm multiplying two things with the same base together, what's going to happen with their exponents so I can simplify? X squared times x to the 5th power I know is x to the 7th power because I'm doing x to the 2 plus 5 power. I'm adding the exponents together. I'm adding the exponents together when I multiply two things with the same base. Logs are essentially another way to write exponents. So they're another way to write exponents. They represent exponents. So if two logs with the same base are being added together, So if they're being added together like these exponents were here, to write them as a single logarithm, you would do that by multiplying. So write them as a single log by multiplication, like we were doing here. So if you see addition with the exponents or with the logarithms, you're actually multiplying the two things together to combine them. Okay, and here is the actual rule. So if I have log base b of m plus log base b of n, I'm going to combine them. They have to be of the same base for me to be able to combine them. To condense them into one, I would do log base b of m times n. So if they're being added together and they're the same base, I can combine them through multiplication. I want to apply the product property to these examples. This is expanded form. I want to condense it. I want to get it into one single logarithm. They have the same base, so I can do that. I can use this formula here. I'm doing log base 4 of 2 plus log base 4 of 8 is log base 4 of, I'm doing 2 times 8. 2 times 8. That's log base 4 of 16. And if I can evaluate that, I'm asking myself, what do I have to raise 4 to get 16? And that is the second power, so the answer is 2. For log of 11 plus log of 10, those are base 10. They're both base 10, so I can combine them. I can do log, I don't have to write base 10 of 11 times x. Since I don't know what x is, I can't really evaluate this any further, so I'm just going to write log of 11x, and that's my answer. For log base 2 of 8 plus log base 2 of 4, I know these are the same base, so I can combine them. It's going to be log base 2 of 8 times 4. I'm just multiplying these two numbers together, 8 and 4. I'm multiplying those two numbers together inside of the logarithm, and that's going to give me log base 2 of 32. 2 raised to the, what power gives me 32? I can answer this. The answer is 5, so my answer is 5. This last one for number 4 has log of 5 plus log base 5 of 10 plus log of 20. 2 of these share a base in common. I can combine those. I can't combine them with log base 5 because log of 5 and log of 20 have base 10. So I'm going to rewrite this as log base 10 of 5 plus log base 10 of 20. I rewrote this one, and I put them together. Plus that extra one, log base 5 of 10. From here, I would simplify log base 10 of 5 plus log base 10 of 20 gives me log base 10 of 5 times 20, which is 100, plus log base 5 of 10. I can't simplify log base 5 of 10. It's not easy for me to do. It's going to be a non-repeating decimal. But I can simplify log base 10 of 100. 10 to what power gives me 100? That's 10. The 10th power, so I have 10 plus log base 5 of 10 is my answer in simplest form. All right, we also need to know the quotient property of logs. So to review, if I have x to the 7th power divided by x to the 4th power, I know that that's going to be equal to x to the 3rd power because I'm doing x to the 7 minus 4 power. If I subtract if I'm dividing two things with the same base, I'm subtracting their exponents. So if I see subtraction, since logarithms are exponents, since if I see subtraction between the two, I can combine them with division. I can combine them. So logs are essentially another way to write exponents. So if two logs with the same base involve subtraction, one subtracted by the other, we can write them as a single logarithm using division, going backwards. This is the equation that we use. Log base b of m minus log base b of n is equal to log base b of m divided by n inside. They have to have the same base for me to be able to combine them. So to start, if I have log base 3 of 20 minus log base 3 of 4, I have log base 3 of 20 divided by 4, which is log base 3 of 5. And that's my answer. I'm going to leave it like that because I can't get a whole I can't get an easy answer of what that would be. I think it would probably be a non-repeating decimal. I have log base 2 of 48 minus log base 2 of 6. If I subtract those, I can combine them. They have the same base. I'm going to have log base 2 of 48 divided by 6. That gives me log base 2 of 8. 2 raised to what power gives me 8? That is the third power, so the answer is 3. For log base 5 of 10 minus log base 4 of 2, I cannot combine those because they don't have the same base. They don't have the same base, but I can simplify log base 4 of 2. So not the same base, so I can't combine them. But log base 4 of 2, I can raise 4 to the 1/2 power. That's the same as taking the square root to get 2. So I can rewrite this as log base 5 of 10 minus 1/2. The power property of logs. If I have x squared to the 5th power, that's actually x to the 10th power. I know because I'm doing x to the 2 times 5 power. If I see a power raised to a power, I know I'm multiplying. So if I see a log multiplied by a number, I know I'm actually going to raise what's inside of the logarithm to that power. So if a logarithm, aka an exponent, is being multiplied by a number, the number inside the logarithm is being raised to that power, whatever number that is that's being multiplied. So this is the formula. If I have x times log base b of m, it's equal to log base b of m to the x power inside of the logarithm that m is being raised to the x power. So let's do an example. If I have 4 times log base 5 of 25, I know that is the same as log base 5 of 25 raised to the 4th power. So I took this number that was in front and I raised 25 to that power. So this is going to be, if I'm actually going to simplify this because I can. I'm going to set this equal to e. I know if I raise 5 to the e power, it's 25 over 4. So 5 to the e power is, sorry, not 25 over 4, 25 to the 4th power. I know that I can rewrite both sides in terms of the same base. 5 to the e power stays the same. I can rewrite 25 in terms of 5 as well. 5 raised to the 2nd power raised to the 4th power. And that's 5e is equal to 5 to the 2 times 4, which is 8. So I know e is 8. So the answer here is 8. For the second one, I have 3 times log base 2 of x. That's going to be log base 2 of x to the 3rd power. I can't simplify that any further. I don't know what x is, so this is my answer. Should put that in parentheses. Should actually have put this in parentheses too here. This should have been written as 25 to the 4th power, like that. For the third one, I have 7 times log base 4 of 8. That's the same as log base 4 of 8 to the 7th power. And I can simplify this. I'm going to set this equal to e. It's going to spit out an exponent. I know 4 to the e power is going to give me 8 to the 7th power. I don't know why I keep doing that. So 4 to the e power gives me 8 to the 7th power. I can rewrite both sides in terms of 2. I have 2 squared to the e power is equal to 2 cubed to the 7th power. That's 2 to the 2e power is equal to 2 to the 21st power. 2e is 21, so e is 10.5. So the answer is 10.5. For the last one, I have 1/2 times log base 3 of 81. That's the same as log base 3 of 81 raised to the 1/2 power. Sorry, I did this again. Oh, actually, yeah. 1/2 power, and this is inside of the logarithm. This is 81 to the 1/2 power. That's the same thing as taking the square root of 81. So I have log base 3 of 9, which I know I'm asking, what do I have to raise 3 to get 9? And that is 2. So the answer is 2 here. I want you to try these problems on your own. Try these problems on your own. For number 1, I have 3 log base 3 of 3 plus log base 3 of 3. What I want to do first, before I actually combine to logarithms with addition, I want to take care of the coefficients. I want to get rid of those coefficients. So I'll have log base 3 of 3 cubed plus log base 3 of 3, and now I can combine them. And I can say they have the same base, so I can say I can combine them because there's addition in between with multiplication. So I have 3 cubed, so I have 3 cubed times 3 inside of the logarithm of base 3, and that's going to give me log base 3 of 3 to the 4th power. I know 3 to the, what do I have to raise 3 to get 3 to the 4th power? That's 4, so the answer is 4. For number 2, I have log base 2 of 24 is equal to log base 2 of 9 over 2. I want to rewrite this as log base 2 of 24 minus 1/2. I want to pull that 1/2 as the coefficient. Log base 2 of 9. Log base 2 of 24, I'm going to write that again, minus, I'm going to get rid of this coefficient. I'm going to move it as the exponent, so I have log base 2 of 9 to the 1/2 power. And that's going to give me log base 2 of 24 minus log base 2 of 9 to the 1/2 power is 3. I know now I can combine these. They have the same base by division because there's subtraction in between. So I have log base 2 of 24 divided by 3. That's log base 2 of 8. 2 to the what power gives me 8? That's 3. So my answer is 3. That's a lot. For the third one, I have 2 times log base 20 of 10 plus 2 times log base 20 of 2. I'm going to first put these coefficients in as exponents instead. So I have log base 20 of 10 to the 2nd power plus log base 20 of 2 to the 2nd power. That gives me log base 20 of 100 plus log base 20 of 4. That's log base 20 of, because there's addition in between, I'm going to multiply the two things inside. So I have 400. 20 to the 2nd power gives me 400, so the answer is 2. For this one, I'm going to rewrite it so that there's a coefficient of 2/3 instead. So I have 2/3 times log of 7. I know that this means that I have log base 10. For this example number 4, I'm going to pull out the 2/3. So I have 2/3 times log of 7. That's equal to log of, I want to get rid of the, when I'm condensing, I don't want to have any coefficients. So no coefficients for condensed form. I have log of 7 to the 2/3 power. I'm going to write this as log of, I'm raising 7 to the 2nd power, and then I'm taking the cubed root of that. So I'm doing log of the cubed root of 49, which I can't simplify, or it's an irrational number, so I'm going to leave it like that. For the last one, I have 2 times log of base 6 of u plus 5 times log base 6 of v. I'm going to rewrite this first one as log base 6 of u squared. I'm going to write this one as log base 6 of v to the 5th power. There's addition in between. They share the same base in common. So I can write this as log base 6 of u squared times v to the 5th power, which I can't simplify any further. This is my answer.